This is where I get confused with Zoom again. How do I make Zoom bigger? How do I get back to my? You told me, oh, those three little dots. Jeez. Zoom. Help me, Felipe. How do I, Zoom minimizes itself and all I can see is me and you. How do I see the chat and stuff?
So
you told me before, you have to put your
If you move the mouse around the bottom of the Zoom window, there's like a little bar that comes up. Or if you press Alt, it should come up.
Alt.
And there's like a black bar at the bottom of your Zoom window.
I ain't got a Zoom window. All I've got is me and you. Jeez, never mind. Anyway, you can drive.
Perfect. I can see the slide, the chat, and the Q&A.
Ah, sorry, I found it now. It's on the other window. Okay, yeah, got it. Sorry, the user is the problem. Okay, so 113 participants.
And growing.
All right, welcome everybody. Do you want to tell everyone about the Q&A and chat?
And I'll put it on the chat as well. So we are going to be using the chat and the Zoom chat and the Q&A today. So any comments that you might have, put them on the chat. Any questions, put them in the Q&A section, and we can go through the questions as they come up. I'll be asking Phil the questions, but put all your questions in the Q&A section and comment in the chat. Excited for this session, mate.
Where's my chat's disappeared? I can see this Q&A. Right, participants, 140, 141, 142. All right, we'll give them a couple of minutes.
It's good. Heaps of messages.
Where do I get the chat? IT support. I can
so
see.
in the chat, people are saying yes, can see the slides. Really good. Ashley says very excited.
But I can see the Q. I've got a Q&A button, but where the hell's the chat button?
So it should be like two from the two buttons towards the right of the Q&A button is the chat.
Mine says pause share. Never mind.
Oh, good. I'll ask you the questions.
Okay. Right.
165. Andrea's in. She's joined. Hey, Andrea. She says hi, Phil and Felipe. Linda says, hi, Phil, looking forward to the presentation. 90 registrations from Monash University. Nice. Go Monash.
Yeah. Ooh, yes. Oh, okay. Found the chat. Right.
Yeah. Paul says, can see and hear. Good stuff. Roy says, glad to be here. Anuj says, looking forward.
Yes. Is it possible to access the recording later? Are you going to video it?
Yep. Yep. It's going on YouTube.
Awesome. Hello. Glad to be here. Hello. Thanks, Roy. Andrea. Hello, Andrea. Right. How many are we up to? 179. Should we get going?
Yeah, let's do it.
Okay, so 4 minutes past 1. Okay, thanks everybody for coming. My name's Phil Briley. I run the data science meetup group. I'll take my headphones off. I run the data science. No, I'll put them back on. I run the Data Science Meetup group, and I'm also going to be giving you a talk today. So probably a lot of you have seen me and wondering what the hell my background is. So you'll probably find out a bit about that today. So
I think people have been mostly wondering, when can we hear from Phil?
Well, in about an hour, I'll be thinking that was a waste of time. Anyway, so thanks to all our sponsors of the group. They're all listed there on the screen. Without this support, these things would never happen. And Felipe in the middle there is Mr. Data Futurology. So he'll tell you about what he's been up to in a minute. And basically, yeah, if anyone else wants to sponsor us, just get in touch with me, and you can have your name up there in lights. Right. Okay, so the catalyst for this talk was came from an internal group at Monash University called the Monash Data Fluency Group, and they asked me to do a talk to them. I said, well, I've got a talk, but I'm kind of had it planned for the Data Science Meetup group, so let's kind of coordinate, and this is the result essentially. So we thank the Monash Data Fluency Group for basically being a catalyst for this, and the directors there, David and David. So thanks to those, and I think there's 90 of those people there today. So I hope you find it useful. And this is where Felipe is going to tell you. Well, you tell us about this slide, Felipe.
Yeah, this is very exciting. So as Phil mentioned, I produce this podcast called Data Futurology, and it's about leadership in data science and AI. So we speak with leaders and executives from around the world, and we get their stories of how they got to where they are. We focus on their mistakes and lessons learned, lessons that they can share with other people, and also they share with us the interesting applications of machine learning and AI that they're doing in their different industries. And the podcast has been running for about 2.5 years. And over the next 3 months, we're doing a special series with an organization called She Loves Data. She Loves Data does free courses for women to learn how to code and how to do data analysis. And they've been doing this for, I think, about 5 or 6 years. And they're all over Asia and Australia and parts of Europe. They've had about 20,000 people go through their courses. So we've struck a partnership, joined forces, and we're doing a 3-month series focused on diversity in leadership within the data science and AI space. We're calling it She Leads, and we have a number of really interesting and high-profile female leaders from around the world. So we're starting with the founders of She Loves Data. Obviously, really interesting people based in Singapore, and they have their own analytics company, and we go through their journey. And then we're hearing from people from McKinsey, from NAB. We have Glenda Chris coming in. We have Catherine Khalifa, who is the Chief Data Analytics Officer from WorkSafe. And we have people from DBS, which is one of the big banks in Asia. And the idea is to have a focused series, so 12 episodes focused on diversity in teams, diversity in leadership, and how that can help your organization. Super, super excited, and that's kicking off next month.
Okay, thanks, Felipe. Just had someone Chris ask a question. Can we hear the presentation? I'm not quite sure whether you mean you can't hear us or not. So I think most people can. But anyway, so we've got lots of events coming up on Data Science Melbourne, and if you go to the screen, the meetup group, you'll see the upcoming events we've got covered. And look, I think the ones Felipe just mentioned, we'll probably put up there as well if you want to find them. A couple of last things before we get into the talk. When I first started the meetup group, or when we first started the meetup group, like 5 or 6 years ago, one of the main reasons I wanted to do it is because I was on the verge of going to America to work, and I kind of didn't want to go to America. I'd rather stay in Melbourne because it's where I wanted to bring up my family. And I like the place, and I kind of wanted to make Melbourne, or help make Melbourne, a place to be for data science. And the meetup groups kind of helped in that mission, I guess. And we're now one of the biggest in the world, comparable in size to places like San Francisco and Washington DC and New York. So very happy we've achieved that. So
extremely exciting.
Please don't go and work in San Francisco. Stay here. It's better. For those who don't know, we run an annual datathon, and this year I wasn't going to do it, basically because of obvious reasons. It's going to be a bit logistically hard, but I kept getting emails from essentially people saying, any chance you know of any jobs or internships going? So what we've done is we've done one this year. It's all online, and basically the main purpose of the event is to give people who are looking for work, whether it's full-time job or an internship, the chance to kind of shine and put themselves in the employment window. So if you are in that position, then jump onto this website and take part in the datathon. It's got about 4 or 5 weeks left to go. So the prizes, we've got cash prizes, and what we're trying to do is guarantee interviews for real internships or jobs. We've got 3 companies on board. If you are recruiting and you kind of you've got a job and you want to interview some of the best students in Melbourne, get in touch with me and we'll see if we can help out. Okay, so that's all the preamble. So this is my talk today. It's a talk I've already done it at a couple of universities. So I thought I'd bring it more up to date and give it as a webinar. So basically the catchy title is Data Science, What They Never Taught Me at University. And there's my LinkedIn, and linking with me if you want to. So basically an outline of what I'm going to be talking about is, first of all, I'll introduce myself and give a bit of context about the rest of the presentation and why I do things the way I do. Then I've been a consultant essentially for 20 years in data science. I've done lots of different projects and lots of different data sets, and I've kind of accumulated a lot of issues that I'm going to talk you through. So they're all going to be real problems I've come across, and I'm basically going to show you a bunch of pictures essentially that you might resonate with you. Then I'm going to talk about issues you can create yourself. When you've got your data set and you're writing code, what you're thinking you're coding is not what always happens. I'm going to give you some examples of that. All examples of mistakes I've made myself and learned by making those mistakes. And then if we have time, which we probably will, I'll talk about how you can, say if you're a data science consultant and you are doing a consulting job for a client, it can take a long time to physically get the data off of the client, and with with a bit of kind of doing it the right way, you can really speed that process up. And then I'll talk about the tools I use. All right, so let's go on to it. So hello world, who am I? Now, I did a mechanical engineering degree. So you might be all saying, what data science, what they never taught me at university. Well, yeah, you're right. I didn't do data science at university. Well, I started my degree 20 years before data science, the word had even been dreamt up. So, I mean, the reason I did mechanical engineering is I kind of always fancied myself as a bit of an inventor, and I was into alternative energy. So I wanted to build windmills and build turbines in the sea that generated electricity. and that's why I did mechanical engineering. And then I did a master's in energy studies, and one of my projects was trying to optimize what's called an external combustion engine. So you stick probes in it, measure temperatures, pressures, flow rates, and things like that. And you'd kind of model them, and that was my kind of my first introduction to modeling. We'd try and predict things and see how we could increase the power outputs. Going back a step, in my undergraduate days, my kind of exposure to what you probably taught these days was, I think I did a term of computer programming and a term or semester of statistics. All my other subjects were, say, finite element analysis or fluid mechanics or stress analysis. They were all kind of equationy and things like that, were not kind of data science type stuff. And pretty well they're all done with a pencil and paper. So I'm showing the edge of it here. And anyway, so in my doctorates, I was still in the energy kind of field, and my research was to try and optimize how control systems worked for heating. And traditionally they're all kind of manually set, and then some guy heard this neural network kind of term. I thought, oh, they can self-learn. So I thought, can we learn the settings of a controller to make our thermal regulation a bit more efficient? And that's how I got into neural networks, essentially. So I spent 4 years essentially. I was in a department that was called Energy in the Built Environment, and no one really in the department knew anything about neural networks. I certainly didn't. So I spent 4 years learning about them, 4 years essentially programming them, and a lot of time essentially developing there's an algorithm called backpropagation, and I spent a lot of time trying to make it more efficient and make the learning, like machine learning, better than it was in the day. So get my mouse on. I wrote my first neural networks in Fortran 77. It was in the last millennium. Yeah. But Fortran, I think Fortran 90 came out just as I was starting, so I did evolve to Fortran 90. And I came to Australia 20 years ago, and I ended up, I'd kind of got into this mathematical modeling or machine learning, and ended up working in companies like the NAB and IBM, and boutique kind of predictive modeling companies. And back in the day, then it was all about marketing. So there'll be a model to tell me who's going to respond to my credit card campaign. Out of my 3 million customers, give me the best 30,000 or whatever. So it kind of evolved a bit from what I thought I'd be doing, but that's where all the jobs were. Currently, I use those skills to trade cryptocurrencies. So it's pretty well the same skill set, but kind of a different market. We're trying to basically decide if the price of something's going to go up or down. Do we buy? Do we sell? And it's kind of pretty live. We're doing that live as we speak, and literally every second we're making those decisions and buying and selling.
Did you mention how you ended up in Australia and why Australia?
I can do. I came on holiday. Still on holiday. I came as a backpacker 20 years ago and ran out of money. Thought I'd best stay and earn some.
Love it.
All right, so I in the early days of Kaggle, I started doing Kaggle. So Kaggle is an online platform for essentially predictive modeling, and I don't know how, but I became the first person to win 3 Kaggle competitions, which included something called the Heritage Health Prize, which was kind of like a $3 million prize money competition, which we won, but it ended up only being $500,000. I didn't get all that because it was quite a big team, so I'm not a millionaire. and also the data science Melbourne organisers. That's me. And now we're getting to the guts of the talk. So first thing I'm going to talk about is terminology issues. So when I started the National Australia Bank, when I first started my job, I was in a kind of couple of small boutique companies. One was a market research company, one was an analytics company. And pretty well, I was the only person doing what I did. So I didn't really speak to anyone else. And then I ended up at the National Australia Bank. And the other people in the team started talking to me, and I'd not got a clue what they were talking about, because I'm not classically trained. I kind of made up my own words for what I thought things should be. And I kind of had to have a quick kind of Google. Well, Google didn't exist, but I had to learn a few things about terminology. So I went to credit risk at the NAB, and people started talking about goods and bads. How many goods have you got? How many bads have you got? I had no idea what they were talking about. And then it was explained to me that someone who's good is a good risk, someone who's bad is a bad risk. And the whole point of credit risk is to say, what good means is you're going to pay your credit card bill. What bad means is you're going to default. And the whole point of the modeling is to differentiate between the two groups of people. Okay, so goods and bads, right, fair enough. In other situations, they will be trues and falses, or yeses or no, or responder, non-responder, or it's some kind of binary outcome. It's the thing you're trying to predict. And there are other bits of terminology as well. So the thing you're trying to predict might be a target. Someone else might call it a dependent variable, an outcome, a response variable. And there are a whole bunch of words that, you will come across. And what I'm saying, if you're a student, or if you've been doing this a while, don't worry if you don't know what people are talking about, because what I find is different industries have evolved different terminology. If you're a statistician, you'll have your statistical way of saying something. If you're in marketing or if you're in credit risk, different terms have just appeared, just morphed out of the same thing. So a new terminology is constantly evolving. So basically what I'm trying to say, don't be afraid to ask if there's something you're unclear about. It's not that you're stupid. You've just learned. It's like someone's learned French, you've learned German. We're all doing the same thing. And just don't feel stupid if you've no idea what someone's talking about, because you actually will. Okay. So that was, yeah, I thought I'd put that up just because I've been in that situation as a kind of newcomer who wasn't classically trained. And yeah, I just ended up making up my own words for stuff that no one else knew what I was talking about either. So, anyway, real data, real issues. So in data science, everything starts with data generation. So data is generated everywhere. So on the left, we've got the first guy, some kind of scientist who's doing experiments. He'll measure what compounds he's got in his test tube there and write them down and do some experiment, and something will happen and he'll write down the answer. The second picture, every time you go to the supermarket, you buy something, it'll be recorded what you bought. In the hospital, when you have an MRI scan, all this stuff's recorded. Social media, every time you turn a light on, that'll be recorded for electricity consumption. So basically all this is kind of the ideal situation here. All this data is collected and it goes into what's called what we'll call a database, that kind of cylindrical shape in the middle. That's the kind of shape for a database. And in fact, I don't know the real terminology. Let's say there's a database administrator who puts all that together for us. Now then, what do we do when we've got all this data? So generally it's no use just keeping it in a database. We'll draw some pictures and some reports. That's typically what happens. We'll have some kind of dashboard. I think these people are probably called data analysts or business intelligence BI analysts, and they'll draw some charts and tell you, how many widgets you sold last week, last month, 2 months ago. Now, the kind of sexy bit comes in then is the data science bit. So it's predictive modeling. So given that we know what happened yesterday, what might happen tomorrow? So given all these things have happened, can we predict what's going to happen tomorrow? And that's kind of, I think that, that's probably what data scientists do. When they've done all that, it's no good just knowing what's going to happen tomorrow. Can we pull some levers so we can make what's going to happen tomorrow what we want to happen tomorrow? And then all that goes back into the database. Hopefully the process is improved. So the scientist at the top, if he's done 3 experiments and he knew some outcome, can he save a lot of time mixing his ratio of chemicals and get to what he wants without having to test every single combination? So that's the kind of ideal situation. That'd be beautiful if that was the way things happened. But this, unfortunately, is reality. No, there aren't just one database. Data's here, there, and everywhere. And the big flaw in the whole kind of cleanness of the thing is that humans are involved. They're just the bane of data's life is humans. And there's all these stars. There's a whole bunch of stuff that's happened through time, like rules change, products change, processes change, software changes, companies merge, data sets get merged, and it just makes data not as nice as a lot of people might hope. And a lot of these changes, I'm going to give you some examples in a minute about where I've kind of come across common things that you should be aware of. So real data is a bit like Felipe's office, or a bit like that. So, but when we're, is that right, Felipe?
Yeah, that's exactly what it is like.
So when we're building predictive models, it's all about the data, and unless our data is square, the model is going to be pointless. So you've probably all heard this before: data prep v predictive modeling. Everyone says data preparation takes 80% of the time. I pretty well agree with that. Model building, unfortunately, that's might be why you want to go to university and learn about TensorFlow and what have you, but that's going to take a very small percentage of your time. The things that you've got to think about: model implementation. Once you build it, you've got to productionize it. These are made up numbers, to be honest, but they're about right. Once you've built it, you've got to monitor it. That's, it's just building a model, and it doesn't stop there. And explaining to people your model is quite important, or else they won't believe in it and they won't give it the nod to go ahead. And yeah, so 100% we like to over deliver. So the reality is, I just rubbish in, rubbish out. Without clean data, you're just going to get rubbish out and everything's a waste of time. The model building bit of it, the statistics, the XGBoost, random forests, that is becoming point and click. You don't really have to know a lot. You have to be aware of the mistakes you're going to make, which that can be another talk, but it's not the hard bit. Correct data preparation, I don't think will ever be point and click, because there's no template for what mess the data's in. There's a lot of different issues. And it's all about caveat emptor, which basically means, it's Latin for let the buyer beware. You are the buyer. You don't trust any data. So yeah, predictive modeling, the whole concept of building a predictive model means that we're going to take some historical data and find a pattern, and then hope that pattern's still obeyed, that behavior is still obeyed in the future. But before we can make sure that the future is like the past, we've got to make sure the past is like the past, which basically means data sanity checking all our data. So some examples of common data issues. Now, these are all ones I've come across in the last 20 years, and you probably will as well. Some of you might have already come across them. Some of you won't. So acquisitions. I titled this first one, acquisitions and events. So what we're looking at here, this is a health insurance company, and time is on the x-axis. So we've got time in months, and on the y-axis, we're looking at how many new members we got in any particular month. This is real data. Now then, you know, just looking at that, you can see a few quirks or odd things. You know, if you were just throwing this into some kind of time series model or ARIMA, you'd really struggle with there's extra stuff you need to know what's going on. Now, when I did this talk before, I kind of made people put their hands up about what they think's gone on. Don't think we can really do that here, but I will tell you. So there's this big spike in member joins, 2000 and something. So what was that? That was John Howard, who used to be the Prime Minister of Australia. He basically made it compulsory to have private health insurance. So in June 2000, there was this massive spike in memberships because it was more of a stick rather than a carrot. People would go and get private health insurance because it's going to be better for you tax-wise. So that explains that reason. Then there's another spike over here, and basically what happened was that was when this is kind of a smallish health insurance company, and they merged with another health insurance company. And you always get this in kind of customer data, well, quite commonly. You basically, they merge two data sets, and well, what do? We've got two customer databases from two companies. How do we kind of, they're now one company, we've got to kind of blend them together. So basically, I guess, one company becomes the main database and the others are just added in. So there's a sudden surge in members here, purely because it was the merging of two databases. Now this, from a modeling perspective, this is quite important because the people who joined in those two spikes are probably a bit different than the others. You know, they're not joining of their own free will. They're just, you know, they might not have the same characteristics as the others. I mean, especially with the acquisition, you didn't really join then. You've got a history before that point in time. So is that really your join date? I don't know. It's things you've got to think about as a data scientist. And then there's a whole bunch of other spikes going on in this data set. And what they are was there's some government regulations that make you release your premiums, what your premiums are going to be for the next year. What happens is a lot of people then shop around to change their policies, and you know, if your incumbent's insurer's price goes up, you might jump ship, go and join this, go and join another company. Now this company's benefited from that. They mustn't have had very big rises, and this is always a benefit to them. They got a lot of new customers because of this. And again, in modeling, you know, this you might want to take note of these people because, you know, they're price sensitive. So you might want to treat them a bit different than the others. So another issue is system defaults and merge data sets. So I've worked quite a bit in the last 6 or 7 years in hedge funds, and every quarter, so this is kind of buying shares in McDonald's or whatever, ANZ Bank now on the stock exchange, and there's certain information you want to know about those companies. So every quarter, a company's got to release a financial statement. And when it comes to knowing if the share prices is going to go up or down, we need to know what dates that statement's on, because it's the content of that statement that can really make the share price go up or go down. If they've met all their targets, done what they've said they were going to do, the price will go up. If they're way off the targets, you know, not delivered on their promises, price will go down. And building our models, we kind of want as much history as possible, and we want to know not just when the financial statement was, but we need to know the exact time of the statement release for a reason I'll go into in a minute. So we went to a company and said, we want as much history as possible on financial statement dates, but we don't just need the date, we need the time. And they said, oh yeah, got those. Now, so I plotted it, and this is what basically came out, and it looks very, very dubious. So first of all, we've got this big spike over here, which is a default date. So any date that they didn't know, it seems they've applied this date to. So that rings a few alarm bells, and it's saying it's probably not the real date. It's probably a system default date. And then when we look at the time, so time is on the x-axis and a number of reports on the y-axis, and I've colored it by what time of the day. So we've got a date time stamp for each record, and it's colored by the time essentially. So the blue is midnight, it's 0000 seconds. So it's all at midnight. So basically what the salesperson was telling was, yeah, we've got a date timestamp, but the time's all midnight. So basically this means we don't actually know the time. So up until 1998, we only had the date essentially. So we're a bit duped, didn't feel too impressed with what we were being told. Now it appears after 1998, we start getting some real times. Now there's another thing here, which is you can see what this data provider is. They're kind of what's called a data aggregator. So they buy up lots of different, they buy data from other people and kind of aggregate it into a big data set. And you can actually, it's not all the same source. And you can see here where in this year 2003, they merged the data set because we've got a whole bunch of records where it's at midnight again. So you can actually see that at the top where we've got more records than probably should be. And there's probably a few duplicates in there because we've probably got one record from one data set that's midnight and another record that's the real time. So basically key messages: don't believe what you've been sold, and always look at it yourself.
And can you go back to the other slide? There's a debate on the chat whether this is a Plotly plot or Tableau. No, the second one that you had on the time. To do a drum roll on
what's the consensus?
No, so either Plotly or Tableau is the guesses so far. Mark says Tableau 100%. Yeah. PM says Plotly.
Okay, so
Aaron says Tableau.
Right, so
heating up.
They're all Tableau.
Ah.
Now I'll tell you why I use Tableau, because when I'm not using Tableau to build dashboards and reports. When I'm data sanity checking stuff, I don't actually know what I'm looking for, right? I don't want to write code going through every single variable to see what it looks like. With Tableau, I can just drag and drop things onto this plot, and I don't know what I'm looking for, so I can't code it up. I'll just drag and drop everything and look at the data in every dimension until I see something that's looking a bit weird. Yep.
Nice one.
That's why, yeah. When I start doing analysis, I'll use when I know what I want to look at. I might use other software, but for exploratory analysis, I love something where I don't have to program. I'll just do what this is Tableau again. So what we're looking at here is the same data set essentially. And when I said time is important, we have basically, I've said before, the market open. The market is essentially the exchange. So it's like the stock exchange. And it might say it opens from 9 o'clock to 4:30. That's when all the trading goes on. Now, you won't release a financial statement during when your shares are being traded. You'll either release it before the market opens or after the market opens, or after the market closes. Sorry. And the reason you don't want to disrupt things during trading session. So this is that same data and plotted through time. So you can see there's a few. The red is where the statements are released during the market open, which is not very many. We've got a few quirks. So there's a lot of statements released at 5:05. That's fine. There's a reason for that if you know how exchanges work. And there's kind of a few odd things. The thing I'm interested in is this 2014 year down the bottom. We've got that suddenly there's a lot of statements being released at 12 and 1 o'clock, which looks odd. Now, I would go back and drill into that data and say, when exactly did those odd bits of data start appearing, because they just don't look right. And you'd probably find a reason for it. Now, the same data again. Now I'm plotting what day was the statement released on. And if you remember, there was a big spike in 1976, and it just so happens that all those records were on January the 15th, and the spikes on February the 15th everywhere else. So we went back to the data provider and said, why is you got so many statements released on February the 15th? And basically what they said was, if we don't know what date it is, February the 15th is a common date, so we just put February the 15th. So that kind of, is not what I want to hear. What I want to know is, if you don't know the date, tell me you don't know the date. Don't make one up, because I need to know the real date, not the date you thought it was. I'd rather know it was missing than made up. But then, knowing this information retrospectively, we can then say, if it's February the 15th, we can assign a probability that it's not really February the 15th. So that's made up dates. I'll skip this one, but it's kind of I'll skip this one. And this one here confused me. I spent a good 2 hours when this was again me dragging and dropping things in Tableau. And I spent a good few hours trying to figure this one out. So I'm plotting on the x-axis. I've got the quarter. It's like not the month, the quarter, every 3 months of a particular event occurring. And on the y-axis is how frequent is that event. So it might be how many members joined our company or our business. And I got these weird dots. You can see the green dots up the top and the purple dots, and what's going on here, and the blue dots is looking a bit odd. So I've colored them by day of the month. So red dots are the 31st, blue dots are the 30th, green dots are the 28th, and pink dots are the 29th. Now, I wasted a good hour getting my head around this, but it's pretty obvious if you think about it what happens, because I've done it by quarter. Depending on which months are in the quarter, there's going to be more 30ths of the months, because some months have 30 days, some months have 31 days. It's just natural. The 28th and the 29th are leap years. So you'll see the 29th, the big pink dots, the 29th appears in 2012 and 2016. So my message there was, don't ever think things. There can be a logical explanation for a lot of stuff. Another made-up date one. So this was my original. The thing that originally got me suspicious of data. So my research was looking at time series forecasting of electricity. So I built this neural network to predict half-hourly consumption, and I think the blue line is my prediction, and the red line was what it actually was, and the green line down the bottom is the error. And I kind of got my model as good as I can, but I was still getting these particular errors. And when I looked into when the errors were, they were on this particular day, Sunday. This is Sunday, the 23rd of October. Now that just so happens that that's when summertime starts in the UK. And basically what I figured out what happened was, some days we'll have, when the hour changes, there'll be one day of the year that only has 23 hours and one day of the year that has 25 hours. Now, how do you deal with that in your database? Basically, one day there you'll have to replicate a record twice, and for another day you'll have to delete a record because it won't fit into your a day can only have 24 hours and must have 24 hours. So that's what I discovered, that my model was wrong, not because my model was wrong, but because the underlying data was wrong. The dates have been fudged essentially. So that was kind of my first ever discovery of how things can't always be as clean as possible. So going back to dates, I always look at the date distributions. So in databases, sometimes dates are a primary key, so you're not allowed to have a null or a missing date. So these database people will make up dates for you. It's not a good thing from a data scientist perspective. We'd rather know if it was missing, it was missing. So you get system default dates. Yeah, as I said, from our perspective, we'd rather know date was missing than it was made up. Okay, another issue is moving definitions of things. So this is hospital data again. So when you go to hospital, you can go for one of two reasons. It's either planned or unplanned. So like an unplanned admission, say you broke your leg, you just rocked up at the emergency department, and that'd be an unplanned admission. So a planned admission was what it would be when you've already been to hospital. They'll say, come back in 3 weeks and we'll take your plaster off your leg and see you. And that's what's called a planned admission. So you need to, when looking at admissions, you kind of need to distinguish between the two. And there's different types of planned admissions. So there's 4 lines here. The purple line down the bottom is unplanned, all the others are planned. Now, you see the orange and the red line, they kind of seem to cross over each other. It's as if someone's got the definition wrong. Now, what probably happened here is the definition of what type of planned admission is subjective. It's kind of a person, a human, enters the data, and it's as if one person's mistaking, like say, unplanned 2 for unplanned 4, and what I suspect went on here is there was a new person. I don't know, maybe someone was on maternity leave or something, and they got a new person doing the coding, and they were getting some definitions wrong. But why this is important, if you were modeling this and you were using, say, time as a predictor, it would tell you that time was important, but it's nothing to do with time. It's to do with the data's wrong at a particular point in time. This is another hospital data set, and basically you get a code when you go to hospital for each kind of stuff that's wrong, each thing that's wrong with you, or each procedure you have, you get a code. And looking at those codes through time, you can see kind of what's going on health-wise in the population. So this one is something called congenital heart disease, and we just plotted these occurrences through time, and you'll see that at a particular point in time, it looks as if congenital heart disease has dropped off the map. Have we cured it? And I took this back to the kind of experts, the nurses, the doctors, and what are called the coders, the people who apply these codes, and basically they know exactly what had gone on here. It was when you apply a code to a procedure, it's basically determines how much money you get refunded from the government for that particular procedure. So each code's got a dollar value attached to it, and they kind of decided there was a similar procedure but different that got them more money. So they started coding up it as somewhat slightly different. So congenital heart disease, the same illness still existed. It's just that it was being defined as something else. So if we were trying to model how many people have this congenital heart disease, its definition has changed. So we need to kind of correct its definition. Again, this is another example of a moving definition. So this was one of the Kaggle competitions, Heritage Health Prize we took part in. So we were given 3 years of data. The top one's year 1, year 2, and year 3. And on the x-axis is this, we didn't know what the variable was, it's called pay delay max. Now we've seen the top 2 charts, there's a big spike right at the right-hand side. In the 3rd year, that's kind of disappeared and it's kind of appeared at the left-hand side. So me looking at this data, so I can't use that variable because something systematic has happened. And if we learn on the first 2, the top 2 rows, year 1 and year 2. Its definition is changed in year 3, so it's kind of not telling us what we think it's telling us. So you've got to always look at your distributions of variables through time to spot that things are still consistent. This is an interesting one. This is kind of made up data, but it's based on true data that I can't show you. But this was the number of admissions to an emergency department in a hospital. And it was kind of a time series. And it suddenly, the number of admissions suddenly shot up for a time and then shot down again. And I went to the guys and said, did you might have been they merged hospitals, I don't know, they might have joined up data sets, but it was not what they explained to us happened. When I looked at the dates, it just so happened it increased the tax year. Yep. So when you go to this is my kind of interpretation of what I remember. When you go to an emergency department, if you are sat in the waiting room for 2 hours, you are classed as an admission, whether you've had anything done to you or not, and you get counted in their database. And for some reason, to try and make them more efficient, it was either 3 hours. They changed the definition of what was an admission from 3 hours to 2 hours, or 2 hours to 3 hours, one way or the other. So nothing physically changed. It's just the definition of what was an admission changed. It was how long you were sat in the waiting room, and it changed back again. So, if we were trying to predict the number of admissions, the definition of what was an admission has changed. So, again, our model, you put time in that model, it'd say time was important, but nothing to do with time. It's to do with the definition. Right, let's speed up a bit because this is my last one on this, I think. This is again trading. So when you buy and sell shares on the stock exchange, historically, if you look at this chart, there's a bit of stuff going on the left. Then in the middle, it's kind of constant, and then on the right, it drops down. So dates on the x-axis, volume, which is the number of shares bought and sold, is on the y-axis. Now, the first half of the graph up to 2007 is explainable by things called share splits. So when shares are split, you kind of go back and retrospectively change how many shares you would have had historically. And then in the middle bit, the minimum volume, you will see this is we've got how many shares you bought in the database, and there was never a value less than 100 until 2014, when the minimum volume was 1. So basically what was happened, it was if you ever bought less than 100 shares, that they didn't record it. Then all of a sudden after 2014, it started being recorded. So you got essentially all the data, which is quite important prior to 2014, because you're getting a kind of a biased sample. Okay, real or systematic. So this is another hospital data set, and what we were trying to do was determine how long you spent in hospital. And we were given this data set, and it had entry time and discharge time. I thought, okay, I'll just take one from the other and look at how long you were there. And then I actually looked at the kind of discharge time. So time of day was on the x-axis and number of cases on the y-axis. And if you look at the top graph, which is all those who had chemotherapy, all the discharge times are on the half hour essentially. So I mean, when you turn up at hospital, you kind of register, and they probably register the time. When you leave, you just kind of wander out, to be honest. You know, so I'm going, they don't register the exact time. So it was a bit systematic. They would know to the nearest half hour when you'd left and allocate that half hour to you. And then at 6, if they'd not got you by the end of the day, everyone who they'd not recorded was allocated 6 p.m. And if you look at the bottom graph, it seems to be different for chemotherapy. It looks as if for non-chemotherapy, it looks as if they've got more of an exact record. So this was a lesson in, we were trying to predict how long you're in hospital, but you're kind of handcuffed by the way they collect the data, and you just don't blindly think discharge time is discharge time. It's discharge time according to the way they collect it. Okay, another project I did was to do with attrition at universities. And one of the pieces of information, we're trying to predict which students would leave. So we could do some intervention and, see if they're okay and see what the problems were. And one of the variables we had was the university exam mark. And when you plotted the distribution, this is kind of this is bins of 5%. So it's percentage on the x-axis and frequency on the y-axis. And okay, it looks okay, but when you actually zoom in, this is the exact same data, and we find a whole bunch of people suddenly getting a pass mark of 50. And basically what happens here is that the marginal students have had their marks manually overwritten, just so they get the pass mark. From a data perspective, we haven't got their original mark, we've just got the kind of manually overwritten mark. So if we're trying to predict, what would we rather have, their real mark or their overwritten mark? We really need their real mark, because that is what they really got, but that's not been recorded because it's been overwritten. So conclusion, there's one thing that's odd here. One of these you shouldn't believe. Keep calm and trust the data. Don't trust the data. Don't trust the data at all. So making sure the data is okay. As a data scientist, that's your number one requirement. Making sure what you've got, it's your responsibility as a data scientist. Don't just because someone's given you a data set, they won't have looked at it as closely as you will, and it's your responsibility to make sure everything looks right. And from what I've just shown you, no statistics were required at all, no TensorFloat required at all you required was Tableau and the data, and there we go. Right, I'll see we're coming to nearly an hour, but I'll just quickly whip through some self-imposed data issues. So we've got the data, we've cleaned it up, and now we're let loose on it ourselves. We're going to start doing stuff to it. So these are some issues that your code won't always do what you assume it will do. And I've made that mistake. I've written code and kind of thought, that's not doing what I thought it would do. And here are some examples. You normally have to learn by mistakes, and these are some I've made. So the first one, integer division. So this is a SQL Server database, and I've got two columns called column A. I've got column A and column B. So column A has got the numbers 1, 3, and 5. Column B's got the numbers 2, 4, and 6. And they're defined in the database as integers. So I'm building some features for my model, and I think, oh, okay, if I divide A by B, that'll be a great new feature. So I divide A by B, and what this is doing is saying, show me what A divided by B is. So 1 divided by 2 is 0, 3 divided by 4 is 0, 5 divided by 6 is 0. And that's not exactly what we would expect would happen. So in order to correct that, if ever I'm dividing things, if you times something by 1.0, not just by 1, you've got to put the 0.0 in, it will change the data type from an integer to a kind of float or real, and you'll get the correct answer. So a lot of people don't know that, and it's actually documented. So if an integer dividend is divided by an integer divisor, the result is an integer that has any fraction of part, the result truncated. So just be aware of that. So sometimes you won't always get what you want. Floats and reals. So all these integers, floats, and reals, they're just different ways of storing data in a database to make it more efficient. So an integer, it won't take up as much storage space. Now there's something called a float and a real. Now I've got two numbers here, one I've defined as a float, one I've defined as a real, and they've both got the values 1.2, right? So as far as I'm concerned, the same. This next statement here says, if the float version equals the real version, then write the same. or else write different. So you see, when I run that, it's telling me 1.2 is different than 1.2, which is not what I expected. I would say they were the same. So a kind of a modification of that is saying if we turned the float version to a decimal and the real version to a decimal, they are now the same. So floats and real is documented. Avoid using floats or reals columns in where clauses where conditions are specially equal and not equal operators, whatever. It's best to turn them to decimals. So again, I never read the documentation, but you know, I've found edge cases where that always happens. Nulls is another issue you've got to be aware of. So a null or an NA, it basically means I don't know what the value is. And when you do calculations on things that you don't know, the answer is always going to be, well, I can't tell you the answer because I don't know. One of the values is unknown. So you see that I've got three columns, A, B, and C. A, B, C. A is 1, the top row, B is 2, C is 3. So A plus B plus C, 1 plus 2 plus 3 is 6, as we see on the top row. But if any of those values is unknown or null, A plus B plus C is always unknown, because if we don't know any one value, we can't tell you the answer because the answer by definition is unknown. That's kind of not intuitive. A lot of people might think 1 plus null plus 3 is 4, or null plus 2 plus 3 is 5. It's just not the case. Now, I first kind of fell victim to this when I was building a predictive model. So my data set was all nice and clean. There were no missing values. And you know, I got a prediction for everything. Then kind of when you productionize it, some values suddenly weren't there. And if the values aren't there, the prediction can't be made. So the prediction will be null. So I started getting predictions that essentially were null, that couldn't be made, which means you've got to deal with even if you've not got any missing values in your training data, it's, you know, make sure you deal with that scenario if it would occur in your live data. Here's a nulls again. This is a kind of quirky one. So this is our code, just in case you're wondering. I've defined a vector called responses, where I'm going to say yes, yes, or y, NA essentially null, and N, yes, yes, don't know, and no, no. So I said, what's the length of responses? So that means how many values are there? So there's 5, which is correct. So this next line says, tell me how many are yeses, and it says correct 2. How many are y's? 2. And then it says, tell me how many are not y. So I've got 5 records, 2 are yes. How many are not yes? Well, the answer is 2. Well, that doesn't make sense logically. If you think, well, if 2 are yes, 2 are not yes, and I've got 5, where's 1 disappeared to? It's because of this NA. Because we don't know. It could be yes or it could not be yes. So, you know, sometimes you just got to be aware that, it's when you know this, you will deal with it. But sometimes if you don't know, you'll trip up. Couple more things before we wrap up. System defaults. So this is a function for reading in a text file in R, and you'll see one of the parameters is tell me what value you want to mean NA or null or missing, and its default is capital N, capital A. Right now, this genuinely caught me out. So when you're dealing with trade data, each company's got what's called a ticker symbol, and the National Bank of Canada, its ticker symbol happens to be NA. So I was just reading data in with the system defaults, and I just, whenever it read NA, it kind of replaced it with null or missing, when I actually wanted it to be NA. So from now on, I always tell it what I want my NA strings to be. So these are all edge cases that you won't think of until they come and bite you. Beware of software quirks. This is another one that caught me out. So what I'm wanting to do here, this is again our code, I'm wanting to add time. I've got a particular date and I want to add a number of seconds and then record that new time with the seconds added in the database. So I started off with this base time of 25th of March 2015, 10 p.m. I'm going to add no seconds to it, so I get the same answer. I'm going to add 1 hour to it, which is 3,600 seconds, and I get 11 p.m. And then I'm going to say add 2 hours to it, which is 7,200 seconds, and I get 26th of March 2015. Now can you see the difference between that row and that row? We've lost the number of seconds, and that only occurs exactly at midnight. So I was writing this data to another data table, and sorry, I was writing it to a text file, and then I was reading that text file back in with a format that I would expect to look like that. And this particular edge case crashed my code because it didn't happen it only happened randomly, but it was not what was expected. Last point, we'll get on to Excel. Just don't go. If you're doing data, now Excel's got its, people like it for doing particular things, but from a data manipulation and whatever, don't go near Excel. It does weird stuff to your data. This article appeared about a month ago. So human genes are being renamed basically because Microsoft Excel was reading them in as dates, and people couldn't figure out how to kind of get around it, changing what was a gene into a date. So this was August the 6th, which is like not too long ago. Damn smileys. Now, I think we've just probably on the hour. I'll wrap up there. A bit more to say, but it's probably not that important. We can do that another time. Let's see if I've got anything else. There we go. Thanks for listening. So hopefully we'll. I hope that was useful, and hopefully we'll get to see you soon in the live events, and I'll probably do another talk maybe in a month or so on some kind of predictive modeling, and we can talk about those. Have we got any questions?
Right, there's heaps of questions.
Have we got time?
Oh, we do definitely, and man, that was awesome. I love seeing those gotchas, and a lot of people putting in there, that they felt the same pain. That thanks for showing the gotchas. People, saying like, you little bastard, and when you were showing some of the Excel gotchas. Really, really good. So let's go into questions. So the questions that come in, feel free to keep putting questions in, and everyone can upvote other people's questions, and we'll answer the questions in the order of how many votes they got. So and a lot of people are saying thank you for a great presentation, really insightful, really informative. Great. Oh, and I see Chaitra in there. Oh, nice. Hi, Chaitra. So the first question, mate, is from Akash, and he says, how important is it to understand machine learning algorithms before using it? He says nowadays data scientists use many machine learning algorithms and just select the best one, but a lot of times they don't know what's happening inside the box. What do you think?
Do you want the politically correct answer or the truth?
Oh, man. gloves off.
In my opinion, it depends what you need to know the gotchas. You don't really need to know exactly what's going on. You need to know gotchas, the what you should do. I mean, it's a lot of it. Most of it's about overfitting. So I'll do a talk next month on the family tree of algorithms. But as long as you know what a decision tree is, or what linear regression is trying to achieve, you don't need to know the equation of how it finds the parameters. You don't need to know that. You kind of need to know that it's doing something that's trying to minimize some loss function. You don't need, it can be useful if you want to go into speeding up algorithms to know maths of it, but I don't think you need to know. You need to know the concept, and you need to know the issues if you don't do it correctly. But I don't think you need to know, you don't need to derive equations of exactly how the Gini splitting algorithm works in a decision tree. Just need to know, what I do is if I can draw a picture and kind of explain visually the objective, I'll leave the maths to someone smarter than me of how it gets to that objective. Yeah. Okay, that's that one.
Nice one. Great answer. Next question from Kyle says, how can rookies create their own portfolio or gain relevant industry experience? Do you know of any events that might be happening to help people get experience, Phil?
I don't know, Kyle, were you listening to slide number 3? So we've created the Melbourne Datathon exactly for that. I'd have a look at that. But apart from that, do things like Kaggle, get a pet project. Industry experience is becoming a bit harder, especially with the current situation, and especially because there are, for a graduate or a rookie, there's a lot of you looking. There's a big pool looking for a finite number of roles, essentially. Okay. Yeah, and definitely you have to de-risk the decision for whoever's looking to hire you, and the way that you do that is, as Phil said, by having your pet projects, using data that you can find online or data that you generate. A CPM wrote a comment here saying that they wrote a notebook to classify their credit card transaction records. So essentially, pet projects, Kaggle. And get your portfolio up and running. And obviously the Datathon. That's a super great initiative. Phil's done all the hard work. There's a question from Eric here. You mentioned not using Tableau for your reports and dashboards. What are you using? It's not. Sorry, that's not what I said. What I said is when I'm looking at data. When I'm doing data exploration to find these quirks, I'm not. I mean, a lot of people will just use Tableau for dashboards. It's also got another use, which is finding data issues. That's what I kind of use Tableau for. People will use dashboards as well. I don't. I don't build dashboards. I find problems with data, and it's a valuable tool for doing that. Just because you don't know what you're looking for. And you can just drag and drop things and use your eyes to visualize quirks and odd stuff.
Yeah, using your eyes, mate. It's the way to do it. And we have a question from Vivian. How to make a career transition from business analyst to data science?
Oh, geez. You can answer that one.
Well, I would say you gotta get amongst it, get involved. Obviously, the Datathon is a great opportunity to learn and to develop the skills. There's lots of good online courses. There's a lot of opportunities in jobs. So when you are a business analyst, a lot of what you're doing is a type of analysis work. So there in those projects, there's always going to be opportunities for you to kind of sneak in a bit of more data science approaches, and doing that, as long as it's adding value to your work, it will be appreciated by the customers, the people that are receiving that analysis. So heaps of opportunities, online courses, Kaggle competitions, Datathon, online courses. Coursera has great online courses, and I saw that Kaggle now has free online courses that they have modules that take about 4 hours to do, and they've been really, really good. So I encourage you to look at those, and then try to, any bit of learning that you get, try to sneak it into your work as a business analyst to try and kind of like morph your role into a data scientist.
Yeah,
Sorry, Phil?
and what I've just shown you is, you've got those. If you're a business analyst, the plots I've just shown you, you've already got those skills. You don't need to know TensorFlow or gradient boosting machines. I mean, a lot of the work is just literally eyeballing data and looking for quirks and following your nose.
Yeah, and increasing your domain knowledge as a result, because you're asking really interesting questions about why the data is like that. Definitely increases your value. There's a question from Ingrid, says, how would fields like data science and fintech interconnect in the future, or do they already?
Don't know. What's fintech?
So financial, kind of like technology applied to financial services. So a lot of these like neobanks, like Volt, 86400, Up, Sinja, they're all kind of like fintech companies that they're using technology to kind of like redo what a financial services organization can look like. And because they're organizations that are digital, end-to-end, usually cloud native, all their data is in modern systems usually, and they're organizations that are being born with data science in the core offering. So usually there's a very strong overlap, very strong alignment, and you see that in some of the companies that I just mentioned. So a lot of scope for them to for data science to add value in the fintech space. Sorry, Phil.
I'm going to say if there's data involved, which there obviously is, then I would assume fintech companies need data scientists.
Definitely. Next question from Ingrid as well. Says, what are the main differences between data analyst and data scientists?
Everyone's just call yourself a data scientist like everybody else is doing. I mean, I've seen some people with questionable skills and experiences call themselves data scientists just because it looks good on your resume. So
you mean this guy?
Focus on what you do. Focus on what you want to do. Don't worry about the labels. There's a lot of people doing very different things in what is generically called data science. So if you're a data analyst, you're probably a data scientist if you want to be. Don't worry about terminology too much, because I never do.
Yeah, I agree. I have in my teams, or in my area, I've got a team of data analysts and they're building insight or building reports, doing insights, but also building predictive models. We additionally have a team of data scientists who are also building models. So the skill set overlap is there's a lot of overlap there, and as Phil says, don't worry too much. Paul says, what about the salary difference? So definitely taking Phil's advice of going for the data scientist title will help.
You put data science in your resume and your salary will treble, obviously. That's what everyone says. I've not seen it.
I think now it's all about the data engineers. I think data scientists, where I think Australia is feeling pretty good with the number of data scientists. I'm seeing a lot more job ads and a lot more competition to get good data engineers.
Right.
I don't know if other people agree, but we'll move on to the next question from Paul.
Yeah.
Says, what has needed to be done with fitting and applying models to cope with 2020?
Good question. Good question.
There we go. That's a good question.
So what Paul's getting at is, because of COVID and everything, a lot of the models we're kind of extrapolating into the unknown. I don't know if what the employment. Everyone said the employment figures in Australia were going to nosedive. They've gone up like in this last 2 weeks because they were using models that we're now in a time where we've not experienced this situation before, so we can't build historical models because we're in a time where we've just never been in a situation like this. So until we've got some data to figure out what's going to happen, it's going to be very hard. You're kind of guessing to an extent. I mean, who would have said who would have said employment rate would have gone up and based on historical data? But when you look at the reasons why it has gone up, you probably say, oh, yeah, that makes sense. But the historical data doesn't say it would. So I don't know. Just be very cautious of your current models. I've been thinking a lot about this, and like, people come out with, might be a kind of touchy subject, but there's going to be a massive spike in suicide rate because of historically, if unemployment rate's high, there's a high suicide rate. But how do you know? How do you know that will apply now? Because there's a lot of other factors that have never been the same as well. It's not just the unemployment rate was high. Homeless people who are probably unemployed now, they were taken into hotels by the government. So, they might, the situation might not seem so bad for them. The job keeper's gone up, job seeker allowance has gone up. So, there's a lot of things that, correlation is not causation. So, we just don't know.
Very true. Easy pitfall there with how crazy this year has been. Question from Travis says, is it better to focus on one particular machine learning algorithm, i.e. focusing on computer vision, focusing on NLP, or be a jack of all trades?
It depends what the problem is you're trying to solve. I mean, as I said earlier, I'm an engineer, so I will only learn. I learn the things to solve the problem I've got. I pick the tool I need to solve the problem at hand. I don't learn a solution and then go and find a problem. So I'm probably not the right person to ask that. You need to know how to use software and realize what the tool is you need, and then just have the ability to go and learn that tool. Or you can do the reverse and learn a tool and then go and find a problem. It depends what excites you.
Nice, good answer. Question from Julius says, what kind of experience do you need to build or to get coming out as a grad to work as a data scientist in a hedge fund? So how can a grad work as a data scientist in a hedge fund?
That's a great question, because when I was I always wanted to work in hedge funds. So
Did you? I didn't know that.
I did my degree. I thought I'll know this thing about neural networks, and then I came to do a bit of marketing and predictive modeling in Australia. And I thought I'd like to try my hand at predicting the stock market, but I could not get a job. I could not get a job in a hedge fund. I tried, but because the HR department said, "What's your experience in finance?" And I said, "Well, 0, but I know a bit about modeling." But I wouldn't get a look in.
They were like, "What's modeling?"
Yeah, they said, "What's modeling?" Yeah, and it was really hard because unless you had hedge fund experience, they weren't interested. So basically, it ended up having to start your own. To be honest, so it's essentially what we did to start our own hedge fund, which is far more fun. So yes, if you think you get a pet project predicting the stock market, and it's not that difficult to build predictive models and start trading yourself. Why go and sell your knowledge for someone else to benefit? You can benefit yourself.
Nice one. And I know that a lot of hedge funds during their interview processes, they value people that have experience in analyzing gambling areas. So there's usually a lot of poker playing that happens in hedge funds, and I've seen people get in by having built algorithms to predict the who's going to win a footy game or a soccer match or tennis, things like that. They always value that. So I guess that's a good tip.
I mean, I know some pretty smart people and who've done well in building essentially trading algorithms, and it's best not to have experience. You don't want to be doing exactly the same as what everyone else has done.
Yeah.
You want to kind of you don't want to be biased to doing things the way you think everyone else is doing them. You want to approach the problem without knowing anything, to be honest. And that way you will come up with something different. And it's only by getting a different approach that you will essentially be uncorrelated to what everyone else is doing. And that's where you can make money.
Nice one. Next question from Chris asks, how about formulating the problem? So in the data science sort of end-to-end value chain at the beginning, there's something around a problem definition. Who should that sit with? How should it be done? Is it part of the data science area? What do you think about the formulating the problem bit?
Good question. When I've done consulting with big corporations, the problem was formulated by some guy like quite senior who probably dreamt up. He had a theory and said, right, I've got this idea. I want you to take the data and go and prove whether I'm right or wrong or not. And most of the time you think, what crackpot idea is this? It's got no legs on it. And that's the kind of way it works. And I just didn't like that. I kind of felt I was wasting a lot of time spending up. I knew what the answer would be straight away. So I did some consultancy one for a hospital, and it works very similar there. So the chief surgeon, he gave me some data, and we did some analysis and showed him what we found. And there was no brief. It was like, here's the data, right? These are a bunch of pictures. You tell me what these pictures mean to you. And after like 3 hours, I can't believe we got 3 hours of his time, because he was the head surgeon, and he said, like, you've just kind of turned the light on for me. So what traditionally happens was he would have an idea. I think that this procedure is, good at whatever. Now he would then go to his data team and say, tell me whether I'm right or not. So it was kind of hypothesis driven. He would have he being the medical man would have ideas, and his team would prove him right or wrong. Whereas the approach I prefer is, give me your data and I'll kind of tell you what the problem is, rather than you trying to guess the problem. And it could be a million problems you can dream up. Let's hone in on what we think the real problem is by just give me the data, and we'll go and root around it, and we'll see what we can find. So that's the approach I prefer. But it can be a bit, a lot of people don't like that, because you're kind of rooting around in the dark a lot without kind of a clear defined goal. But it can be quite beneficial.
Agreed. Good. That's a good one. Next question is from Danny, and it's a question I'm also curious to hear the answer to, mate. Question is, how did you manage to keep a record of your pitfalls? Do you have an archive of your lessons learned somewhere? And can we get access to the archive? Good question. That last bit wasn't in the question, but I'm keen.
I guess the answer to that is a lot of what I've just presented. I was kind of working for a few years as a consultant, and I had this idea of doing a presentation, and I kept coming across all these. So I kept just doing screenshots of charts, and I'll put that in a talk. So it wasn't really I don't document them. I kind of remember them, but all what I've shown you was kind of with the intention of documenting them for a presentation, to be honest.
Yeah, nice one. Yeah, I was wondering, because I for one have a terrible memory, and so there's I don't know, maybe a handful of things that I remember at any one time. So I think it seemed like you had a good system around capturing those gotchas, which I guess comes through the curiosity that when you're working in a new problem or working on a problem and something that is totally unexpected comes up, you just go, oh, well, that's weird. Let's save that for later.
Yeah.
Yeah, I like it. I know we're almost out of time, so maybe I will say 2 more questions, or maybe 1 actually, then the other ones have all the same votes. So last question is, what are some of the strategies you use to combat missing data points?
Well, I think I've turned that question on its head. And from what I've just told you, I'd say when I don't have any missing data points is when I raise questions, because what happens is, as I said, if something's unknown, I would rather it be unknown. I would rather know it's unknown than it be made up. So the first thing is, first of all, we want to know what's unknown rather than that someone make up a piece of information for you. So given that you've got a bunch of unknowns, I guess the question is then, how do we model them? So say had age, we had an age for 90% of people and an unknown age for 10% of people. If I was building a model, I'd just create a second field which was age unknown. So for 10% of people, I'd stick a 1. For 90% of people, I'd stick a 0. And then where it was unknown, I'd just maybe stick the average value in. And those kind of 2 fields in combination can kind of, rather than, because we've got the average value and a flag that's indicating that it is a made up value, in combination, those 2 fields can adjust the average to what it might be, rather than what we think it should be. So that's kind of one approach, but it's a kind of whole topic in itself, what you can do with unknowns. But I don't like a lot of people will impute unknowns. I'd rather let my algorithm itself do that imputation by doing what I've just described, rather than first of all imputing it. I'd rather let my algorithm try and figure out what is the best imputed value for the problem we're trying to solve. There we go.
Right, that was fantastic. Mm-hmm. Thanks so much for sharing all that. And you said you're doing another presentation in a month?
See what Dan said. If Dan's got us still in lockdown next week, we'll I'll have time to put something together. But yeah, we'll do one about algorithms themselves. Probably similar to the one I did at the data meetup group a year ago. Do it online.
That'd be great. Well, we should set up the time and make it a session about the same length as this one. I think an hour and a half is good to get through. Enough.
I could finish the rest of this one. That might take another hour.
Yeah, exactly. But that's I like that approach.
Okay.
Thanks everyone for joining. I hope you enjoyed the presentation. The presentation is going to be up on YouTube, and definitely come back for the next webinar. And keep your eye on the Data Science Melbourne meetup page, and hopefully you will participate in the Datathon as well. And if you're looking for some content to listen to during lockdown, remember the She Leads diversity series that we got coming up in data futurology, October to December, female leaders around the world. I hope you enjoyed this presentation. I know I did. That was awesome, Phil. Thank you so much.
Okay. Thanks, everyone. Thanks.
Take care, guys.
Thanks, Felipe. Cheers.
Thanks, Ryan. Talk soon.
Bye.
Bye.